Kia ora tātou. In this video we'll introduce the equilibrium constant. So the equilibrium constant describes how far a reaction goes towards completion. So if we had a reaction of A plus B, goes into C and D. So this is the same kind of idea as what we did last video. C plus D. The equilibrium constant is shown by the symbol Kc, so capital Kc equals the equilibrium constant. So if the value of Kc, and this can be shown at any different temperature, but it'll be the same for any reaction. If the it'll be a unique value for every different reaction. So it needs to be worked out experimentally for each reaction at a particular temperature. So let's say we've got the equilibrium constant at 25 degrees for this reaction of A plus B going into C and D. If the value of Kc is greater than 1, then that tells us that at equilibrium we're going to favour the products. So that means there'll be a greater concentration of products than reactants. If Kc was less than 1, then we would favour the reactants. And if Kc was somehow equal to 1, they would be equal. But you'd be very unlikely to see that. Often you'll get very small numbers, so it might be 1.0 times 10 to the power of -8 or something like that. So a very, very small number indicating that it's pretty much all reactants and very few products. Or we might get a very large number, like let's say 1.5 times 10 to the power of 15. And that would indicate that we've got pretty much all products. If we get really, really large like this value here, then that's effectively indicating that it's going to completion and it's not really an equilibrium reaction. So you'll come across the small numbers more than the large numbers, but you can get these different values for Kc tell you how far an equilibrium reaction goes towards completion. And that is all you need to know for the equilibrium constant itself. In the next video we will look at how to write the equation to work out the equilibrium constant. Thanks very much. See you then.